Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have discussed about that is how we can prepare carboxylic acid, that is preparation of carboxylic acid. Along with that we have also discussed about the physical properties of carboxylic acid. So now in this topic we are going to cover that is chemical properties of carboxylic acid, or we could say that is reaction by carboxylic acid. So now let us understand that. So friends, in this lecture we are going to cover that is different reactions that could be exhibited by the carboxylic acid, and for that let me start the first one. The first one is that is action of active metals on carboxylic acid. So let me give you this with the help of a general reaction. We understand that is R C double bond O OH is nothing, it is known as carboxylic acid. That is a general formula for that. And suppose if we are reacting it with active metals like suppose if I am considering that is sodium. So it has been found that is the carboxylic acid, it is reacting with that of sodium with the evolution of hydrogen gas. So for that we can find that is this carboxylic acid, it will react with sodium. But talking about sodium, sodium is basically univalent, that is it has a valency of 1. So it is known as univalent metal, and that is how we have to mention here as that is 2 moles of that is carboxylic acid that will react with that is 2 moles of sodium, so as to get that is 2 moles of R C double bond O ONA. Along with that is there is 2 moles of hydrogen atom, so therefore they will combine with each other so as to form that is hydrogen molecule. So this is how the reaction proceeds, and this is how there is a reaction of the sodium with carboxylic acid. So even that we can also determine the presence of the carboxylic acid. What we have to do is we have to take the carboxylic acid and we have to add, or we have to consider a compound and we have to add that is sodium in it. Suppose if we have a carboxylic acid, or suppose if we have a compound and if we have added sodium in it, so there will be evolution of H2, and that could also say that there is a presence of carboxylic acid, or it could be alcohol also. So suppose if we have considered the carboxylic acid, that is CH3 C double bond O OH, that is known as acetic acid. So what we have to do is we have to consider that is 2 moles of that is acetic acid, we have to react it with 2 moles of sodium, so that the product that we could get here is basically 2 moles of CH3 C double bond O ONA. That is nothing known as, it is known as sodium salt of carboxylic acid, or we could also call it as sodium salt of that is acetic acid. Along with that will be evolution of that is H2 molecule. So this is how the reaction proceeds. So this was related to the reaction of active metals to the carboxylic acid. So we can also consider that as the other metal like potassium. The reaction will be the same, and the product that we could get is, it would be that is potassium salt of carboxylic acid. So we can also react it with that is calcium, we can also react it with magnesium. So talking about calcium, that is calcium has a valency of 2, so that is the reason that 2 molecules of the acetic acid, they will combine with 1 atom of the calcium, and there will be evolution of H2. So this was the reaction of the active metals with the carboxylic acid. So now let us move on to the next one. So the next one is action of NaOH on carboxylic acid. It is a very simple process. That is, suppose if we have considered the carboxylic acid, that is nothing but R C double bond O OH. And what we have to do is we have to react it with NaOH, and this is what we are representing NaOH. But we understand that is this is carboxylic acid while this is a base. So therefore the reaction is known as neutralization, and that's how we can produce that is water molecule, as well as we can also produce salt by this reaction. So it has been found that is this H, it would be replaced by the Na, that is the sodium atom. So that is the reason that we could get that is R C double bond O ONA. Along with that is the H2 molecule, it will be as a byproduct. So this kind of reaction is nothing known as neutralization process, and this is how we can produce that is sodium salt of carboxylic acid. So this was related to the action of that is NaOH on carboxylic acid. So for that, suppose if I consider the another example, suppose if I consider the same thing, that is CH3 C double bond O OH, that is acetic acid, and suppose if I am reacting it with that is NaOH. So the reaction will proceed in such a manner that is, we could get CH3 C double bond O ONA, that is sodium salt of carboxylic acid, along with that of the water as a byproduct. So this was related to the second reaction that we have discussed, that is action of NaOH on carboxylic acid. So now let us move on to the next one. So the next is action of NaHCO3, that is sodium bicarbonate, and Na2CO3, that is sodium carbonate. So what is the action of sodium bicarbonate as well as what is the action of sodium carbonate on the carboxylic acid? This is what I'm going to represent with the help of a general reaction. So for example, if I'm representing that is RC double bond OH as the carboxylic acid, and suppose if this is reacted with that is NaHCO3. So it has been found that is the product that we could get is nothing but RC double bond ONA, because this hydrogen it will be replaced with the help of the sodium, and this hydrogen along with this hydrogen it will be removed in the form of water, that is H2 will be removed, taking away this oxygen atom of that is CO3, and the thing that has been remaining as a byproduct is carbon dioxide. So this is how basically we can get that is sodium salt of carboxylic acid, and along with that of the evolution of CO2 along with that of the byproduct as H2O. So this was related to the action of that is carboxylic acid to the sodium bicarbonate. So now let us understand the general reaction, that is what will happen for the reaction. So now let us understand that is what happens if the carboxylic acid is treated with that is sodium carbonate, that is Na2CO3. So in this reaction also the product will be the same, that is we could get that is RC double bond ONA. But the thing is here we have used that is 2 atoms of sodium that is present in that is Na2CO3, or we could call it as sodium carbonate. So that's the reason that we have to use 2 moles of that is carboxylic acid, and we could get that is 2 moles of sodium salt of carboxylic acid along with that of that is H2O and carbon dioxide. So this was just the general reaction. So now let me give you the example related to this reaction. So for that, suppose if I have considered that is CH3 CH2 C double bond OH. This is known as propionic acid, and suppose if that reacts with that is NaHCO3. So the reaction proceeds in such a manner that is the product that we could get is nothing but CH3 CH2 C double bond ONA along with that of that is H2O, as well as we could say that is the carbon dioxide is also been evolved during this reaction, and that is how we could get the product as sodium salt of propionic acid. So this is what the reaction is, and now let us move on to the next one. So now let us talk about the action of PCl3 on carboxylic acid. PCl3 is nothing known as phosphorus trichloride. So for that, let me give you the general reaction. That is again we are representing that is RC double bond OH. And suppose if that reacts with PCl3, that is phosphorus trichloride. So what we have to do is we have to, for this to represent this reaction, we have to represent the balance reaction. So that's the reason that we are representing here as that is 3 moles of that is carboxylic acid. It will react with PCl3 so as to produce that is 3 moles of C double bond OCl, that is nothing but acyl chloride. Along with that of there will be evolution of H3PO3. So this is how the reaction proceeds, and this is what the reaction of PCl3 with the carboxylic acid is. So for that, let me give you the example. That is, suppose if we have considered that is CH3 C double bond OH, that is acetic acid, and suppose if it reacts with that is PCl3. So what we have to do is we have to balance the reaction in such a manner that is we could get that is 3 moles of CH3 C double bond OCl along with that of that is H3PO3. So the product that we have obtained over here is known as acyl chloride, and in this case it is known as acetyl chloride. So this is how the action of PCl3 is on the carboxylic acid. So now let us move on to the next one. So now in this we are going to talk about the action of PCl5, that is phosphorus pentachloride on carboxylic acid. So carboxylic acid, that is we can represent, I'm representing the example over here, that is suppose if I consider that is CH3 C double bond OH, and suppose if I'm reacting it with PCl5. So it has been found that is whenever the PCl5 it has been reacting with the acetic acid, the following product that we could obtain is that is CH3 C double bond OCl along with that of the product as or the byproduct as HCl along with that of that is POCl3. So this is how we can obtain the acetyl chloride, or we can obtain that is acyl chloride due to this reaction. So this was the reaction of PCl5 with carboxylic acid. So now let's move to the next. So the next is action of SOCl2, that is thionyl chloride on carboxylic acid. So for that we have a general reaction that is RC double bond OH, and suppose if it reacts with SOCl2. But this reaction occurs in presence of a strong base, and that is nothing but pyridine. So with the help of pyridine, what the product that we could get that is RC double bond O Cl along with that is SO2 along with that is HCl. It will be removed in the form of a byproduct. So this is how we can also obtain that is acyl chloride with the help of the reaction with that is carboxylic acid along with that is thionyl chloride in presence of that is pyridine. So this is how the reaction proceeds, and we can obtain a higher yield of that is acyl chloride due to this reaction. So now let's move to the next one. So the next reaction is action of alcohol on carboxylic acid. So for that we have that is RC double bond OH as the carboxylic acid, and suppose if it reacts with that is ROH, that is alcohol. So it has been found that this kind of reaction is known as esterification reaction. The reason behind that is the product that we could obtain is nothing known as ester, but this reaction only proceeds in the presence of HCl and at higher temperature. So this OH of the carboxylic acid, it will move along with that of this H in the form of that is H2 as a byproduct, and the product that we could obtain over here is that is RC double bond OR. That is nothing but an ester. But this R group or this alkyl group that can be different also, so that is the reason that I am representing it with R dash. So this is what the esterification reaction is, and the reaction it include or it should have that is acidic medium. The reason behind that is we are removing H2O, and this H2O has a tendency to react with ester so as to form again that is carboxylic acid and alcohol. So that's the reason that the condition that we should maintain here is the acidic condition, and the temperature should also be high. So this is nothing but the action of alcohol on carboxylic acid. So now let me give you the example related to this one. Suppose if we have considered that is acetic acid, that is CH3 C double bond O OH. And suppose if we are reacting it with that is ethanol, that is C2H5OH. The reaction proceeds in the acidic medium. That is the reason that we are mentioning here as HCl along with that of a higher temperature. So therefore the product that we could obtain as a byproduct is basically H2O. So therefore this OH, it will take away this hydrogen atom of the alcohol, and the byproduct that would be removed is known as H2O, and the main product that we could get is nothing but CH3 C double bond O, and this is C2H5. So the name of the product that we have obtained over here is, it is known as ethyl ethanoate. That is nothing but an ester. So this was the reaction of the carboxylic acids, and this is what we are done with. So that's it. I hope you have understood this lecture very clearly, and I hope I will see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.